So see if you can open up this blank Google Doc and everyone write your name in there. Oh yeah, look at everybody coming in. All right, so go ahead and try to claim a page for yourself. Insert a page break and put your name at the top of a page. And let's see if we can get everyone on their own page. See if we can fight it out here. I don't know. This could just be Lord of the Flies. This could be chaos. I don't know.
Alright, can you repeat again where the Google Doc is? Yes.
Oh, it's in the classroom. So if you go to the classroom.google.com and then you look for 200, lecture 2, there is, if you open up that box, you should see this Google Doc. So I hope we're not, okay, people seem to be getting it to work. Okay. So today we're going to do it all individually. The next time we do an in-class exercise, I'm going to try to do it with groups and do breakout rooms, but I don't want to introduce too many, things that are going to break all at once. So, so we'll try this. Let's see, Riley and Ben. Oh, there you go, Ben. You jumped to your own page there. So I'm hoping there'll be 15 pages to this and 15 names at the top. Riley and Ben, you're still fighting it out. Okay, Zach's there. Mike. Jameson. Peter. Okay. Okay, good. Who's on the first page here? This is, oh, it's John Don. Instructor. Okay, I'll be on the first page. All right, so let's keep that open. We're going to go through algorithms and we'll get to some triads. And then for the triads, I would like you to insert your response on this Google Doc, and then we'll be able to share it with each other and try this out. So let's go to the slide deck. I'll post it on mine. I'll post it to the Google Classroom too, so I'm gonna get better at this. This is not gonna be as painful every day. Let me add the slides to this as well, so that you can see them. Classroom 200. All right. Save. All right, John. I can't play Minecraft right now. But you can grab the laptop somewhere. Talk to Mom. She can play it on her laptop.
Where is my laptop?
This is going really well. Yeah, this is all very good. All right, so you should be able to see the lecture in your. I don't know. You get it? Okay. Oh, okay.
Sir, can we start a class server, Minecraft server?
Actually, yeah, I run a server in my basement down here, and yeah, if you guys are into it, then you can do these coding tutorials in Minecraft, so we can spin it up as a learning exercise.
You just do class in Minecraft, sir.
That's what we should do. It'd probably go better.
Logic here.
Sir, mods.
Sir, I'm willing to route a chit in order to do class in Minecraft.
I'm gonna take it into consideration. I'll think about it. I'd be curious to just see the crazy nature of mids turned loose on Minecraft in my basement. What would happen to that poor server? But maybe my son would love it. All right. Seriously though, we need to learn today. Okay, so lectures. You should see the basics of algorithms in here. I'm going to pull it up myself, and I'll share my screen with you so we can go through. And let me try to find a good triad here for us to work on. FLs, nested FLs. Okay, yeah, here we go. Go ahead and let me. Oh, shoot. So I'm just gonna make it big here for a second. If you look in the slides, you're gonna realize this isn't quite right as far as the whole screen. But let's look at this. Build an algorithm to read two numbers from the keyboard and output the one with the largest magnitude divided by the other. So I think we'll probably have to, unpack this. I don't know that you're totally ready to do this by yourself yet, but let's use this as a prompt. So everybody see on slide 21 here? So I'll copy this out and put it in the Google Drive. Right, so we're going to read two numbers from the keyboard, and then we need to figure out which one's bigger. And so go ahead and have the first page of this Google Doc open. And then we'll divide the bigger one by the smaller one, okay? And so if you look on the slide, we've got a list of operations we're allowed to do. And this is going to be, kind of the critical part of our programming in 200. We'll have a set of, we'll call them functions that we can call, and someone else has written them for us. We don't have to worry about how to read a number from the keyboard. We'll just call it, say, read number. That's fine, right? But figuring out which one's bigger, that's kind of an algorithm question. So we'll want to use that word if. And then we can use a word like print to indicate, showing something to the user. So let's say we have the following tools available to us. So basic math, print, which displays something to the user, and read, which requests a number from the user. Okay? Is everybody on the Google sheet? Like, you can see what I'm talking about here?
Sir.
Okay. So this is our library of operations. Okay. And we just want to use, we'll call it pseudocode, but let's just have everyone try this out first, and then we'll kind of converge on a sort of set of best practices and talk about how we forming the right pseudocode. So there's no strictly right answer, and if you've done programming before, feel free to write it in a programming language, but just make it up, right? See what you can do. I'll give you about 5 minutes here, and then we'll pick a few pages to look at as a class.
So can we use the if-then statement?
Oh, please, yeah.
Yeah.
That's what you'll need
Okay.
to do, yeah. Like, that is an intense font you've chosen for yourself there. So if you're stumped, feel free to scroll around the document. This isn't like a quiz where I'm concerned about individual work. Feel free to get inspired by each other. All right. Why don't we go ahead and talk it out? So for the first minute here, go ahead and scroll down and look at someone else's or multiple people's code if you haven't done so already. And I won't pick on anyone in particular here. Just we're starting out. I want to make sure everyone feels comfortable. So we'll just talk in general about it. But now that you've all had a chance to think about it on your own, hopefully your mind is all warmed up for this. All right, so go ahead and then scroll to the first page of the document, and let's just let's talk through this. And I will put up a whiteboard here. We'll draw some stuff out. All right, so let me see all your cursors. I see Megan's on the first page. Go ahead and bring your cursor up to the first page here. It's a crude, tool, but it makes it look like everyone's, clustered around the document. Okay, so the first thing to do, right, is define the problem. And I've given you this kind of English statement here. We might want to break it apart a little bit more, and really, by putting it on 3 different lines here, I've tried to do that, but let's make it explicit. There's really 3 tasks. Okay, the first thing we want to do is read in 2 numbers from the keyboard somehow. We have this, and then we want to do some comparison, maybe with an if. And based on the result of that, we want to divide the bigger by the smaller, and I guess and display the result, right? Okay. So how are we going to do this? I'm going to switch my font over to like Courier. We usually use a fixed width for programming. That way our code lines up nicely. So step 1, whenever you have a program, it's nice if it prints out its goal and some instructions when you first run it. So even though the number one is a read command, if our program starts right up and just asks us to, and just has a blinking cursor, it's hard to know what we should do. So let's go ahead and say print please enter 2 numbers. Okay. And then I can say, now I'm going to grab those numbers. I'm going to say x equals read and y equals read. Now, how you define these things, this is pseudocode, so you can have a bit of flexibility in how you write this stuff. I'm going to show you some general rules here, but this isn't like the right answer versus the wrong answer. In general, I want to see 2 read operations. Or if you've somehow decided your read can read 2 numbers at once, indicate that you're putting it into 2 separate variables here. Remember, this equal sign is really an assignment. So really it's something like, an arrow. Read this number, do this operation, and stick it into X. Okay? And at this point, I've got 2 quantities, an X and a Y, and now I can do something with it. Hey, if X is larger than Y, do something else, do another thing. I want to point out how I've decided to write the kind of values here. Notice these print and read. We're going to call them functions, okay? And print, in order to call print or execute this print operation, I have to give it a little bit more information, right? I have to tell it what to print. So this box, this tool print here requires some extra information. We'll call that an input, okay? So I've put this input in parentheses here. And I put double quotes because that's what you do when you're programming, but double quotes doesn't matter too much. Read takes in, maybe that you want to read a number, but then it has this output equals, and see this equals is assigning something to read. So let me show you how I like to think about these operators. So if we look at my whiteboard now, if you're in the Google Drive, just switch over to the Zoom tab here. And if I think about these these operations as blocks, right? They're black boxes. I don't know how they work. I'm glad that I have them. I'm glad that I have the ability to read information, and I'm glad the ability to print information. Okay. So read here. Can I do this? I'm still learning all my my tools. Okay. So when I say read, this thing is a box that can produce some output, right? And I'm going to put that output, I'm going to save it. I ran this thing read and I put it into X. I have other built-ins that take inputs. I didn't draw that well enough for it to recognize it as a square, but it's okay. And this print has inputs, right? I have to give it something. The message that I want to write to the screen. And other built-ins might have inputs and outputs. I don't really have an output from print. Like this, it doesn't give me back anything. And I don't give read much. I mean, I guess I could say I wanted to read a number here. But notice how in my pseudocode, how I write the output of a box is setting it equal to something. That I'm reading this thing and I'm setting it equal to X, right? And then I put on the right-hand side of print, I put the input to it. So I guess with this block diagram notation, the order is a bit flipped here. But it's important to understand that these built-in operators, the things that we're told that your computer somehow knows how to do, are boxes that have inputs and outputs. Some might have, no inputs and only outputs. Some might have a combination. But let's, as we look at the built-in tools, let's try to classify them as operators that either have inputs or outputs or both. So print is a tool that has an input, and I'm going to give it to it on the right. And then read is something that produces a value, and I'm going to store it on the left here. Okay, so if that doesn't make total sense, hopefully it will once we really start talking about the syntax of particular programming languages. But that's step one here, okay? So step two, how do I figure out which one's bigger? That's a question, right? And it's a question with a clear answer. Or at least I need to, if it isn't clear to you now, let's make sure that it's a yes or no answer. There should be no ambiguity to this question, right? An if statement has to be true or false. It can't be maybe. So who can phrase an if statement that has a true answer, like a true or false answer for me based on X and Y?
If X is greater than Y.
Okay, perfect. So if X is greater than Y,
Print X divided by Y.
perfect. Print okay, and this if I'm going to also put bold, but I'm going to make it a slightly different color. I'm going to say this is a reserved word, okay? This is a special word that is a part of my programming language. I can't use it as the name of a variable, right? Or the name of a built-in operation. So if is X greater than, then print X divided by Y. And what would I do to print the other way?
I'll print Y divided by X.
Sure.
Sir, what if the two variables were equal?
Good question. In some cases, there will be some kind of corner case that is not well defined. Maybe in that case, what would we do here? If they're equal, we would print Y over X, right? Because that's else. You could say something like, if we really cared, well, let's change it up now. Rather than dividing the biggest by the smallest, say, so what about that? What if we had changed 3 to, instead of just dividing the two, print a little message saying, hey, the first number is bigger, or the first number is smaller, or the first number is equal. Okay, that's going to require us to do something like we did on Friday, where we put together two different if statements in a clever way. But in particular, for this question here, it doesn't matter. What if, right? If they're equal, the answer is going to be 1, and so whether we divide one by the other or vice versa, it won't particularly matter here. But I like your
0.
What's that?
If they enter 0, then wouldn't it be like a compiler error?
Oh yeah. Well, now this is very good, right? So and I would throw something back at you. What if they entered bad egg and they refused to type a number? So in general, users are your worst nightmare, right? Your code will hardly ever survives first contact with the user. For this class, we're going to assume a well-behaved user that is really on your side. In more advanced classes, if you come see me again in the 430 series, we'll talk more about how to sanitize user input and how to deal with errors like dividing by 0 and stuff like this. But for now, let's just hope that they don't do such an evil thing. Right, you can imagine adding more if statements. It's basically just adding more code to deal with these problems. But good catch. So let's try to keep it simple for here, though. And how would I modify this? So rather than printing out the result of a division, I actually print out a message.
I mean, instead of having print X divided by Y, you could just print a statement and then have a nested if else. So in the else,
Yeah. Well, here let's
But-
give someone else a chance here. I like where you're going with this. This is great. Who haven't I heard from yet? I don't know. Daniel, have we? You there? Let's see.
Yeah, I'm
So-
here.
So we're gonna switch out for number 3 here. We're gonna print a message instead, and Hannah already got us started that rather than doing this x divided by y, I'll say print first. Okay, so that gives me this piece here, but I've got 2 other messages, and I want to know where to print them, how to do that.
Could we just do like else, and then if first number equals, or like if x equals y, then print first number is the same as second number.
Something like that. Is this what you're thinking, Daniel?
Yes, sir.
Great. Then that would be the right thought. Yeah, so let's look at this. Already I see a problem with my programming, my fake programming language we just made up here. I've got kind of ambiguous symbols. Look at the beginning where I read in the numbers and I said x equals read number. You see that? I'm using equals in the context of assignment. Assign the output of the read block into the x. And then based on Daniel's input, and I agree with Daniel, I think he's got the right logic. But as far as writing this down, is the computer going to interpret this as assign y into the value of x, or in the mathematical sense of are these 2 things balanced? Are they actually equal? You see this ambiguity?
Can't you use like double?
Two equal signs.
Yeah. So maybe you've seen some programming before, but basically that's how programming languages developed, right? You start being like, I can make this happen, and then you realize, oh no, what am I going to do here? And let's get creative and just make it 2 equal signs in a row, right? And so we'll see in MATLAB and in C, and in most programming languages, that's how it's done. So this is mathematical equality, a question, and that question can be true or false. It can't be anything else, right? Just like in math, right? You either got the answer and it's equal to the right thing, or you didn't and you got 0 points. Okay, so this double equal sign here will cause you amounts of pain, varying amounts of pain, but some pain for sure, right? I think every year I see students that get confused on whether to put a single equals or a double equals here. Okay. MATLAB will politely give you a notice like, hey there, it's unconventional for someone to use a single equals here. Would you like to change your... Oh, thank you, MATLAB. C will just be so excited. It will be like, haha, guess what I'm going to do to your hardware? Blow it up, right? And your robot will just not do the right thing. And we can talk more about that in C, but be careful here, okay? And I think coming at it from this angle where we've kind of realized it's necessary to have a different syntax for equality versus assignment, hopefully this makes it stick a little bit better. Okay. Also notice how I've used whitespace. Whitespace is the name we give to any characters that don't result in like kind of graphic results in the screen. And it's very tempting to just eliminate all whitespace. Students love to do this. Just delete it all, have it lined up on the left margin. By indenting, we can visually see very clearly the 2 parts of this if statement, the branch, right? Either go this way or go this way. Okay? It's clear that this else belongs to this if. And not some other way around. So when you're writing your pseudocode, make sure you indent your blocks. We'll call these blocks. And then here we only had 1 line, so it's a very small block. But you could have as much code as you wanted here. Okay. You know, something like this, and then, you know, read. And you could say if answer. Then all of a sudden in here, you would start saying, you know, and maybe that would be a built-in block that would all start running Minecraft. Just based, you know, shooting from the hip here. Real life situation. Okay, so this is all part of the code that would execute if x was greater than y. You see this Google Doc here. Okay? Else, do these pieces here, and you would never even know there was a Minecraft server secretly embedded in here. Okay? This would be something, I don't know, like an Easter egg, right? Like, who would suspect that if you played my silly game of entering 2 numbers, you could actually start a Minecraft server? And sometimes people like to embed these little code tricks into their projects and see if anybody finds them. So do you get the kind of intuition for how we use if and else statements in code to go one of 2 ways? And if we want to go 3 ways, we just embed another if statement inside of the condition. And you can go more and more and more, right? Basically what we're doing here, if you go back to looking at this sketchpad, we're building a decision tree, right? But our tree can only have 2 branches at any level. So if you wanted to have one of 8 possible outcomes here, what I would do, or what is this, 7? Then you would say if this situation, else maybe this situation, else, and so we're gonna kind of build these questions up, right? And each one of these could correspond to one of these results. So just by having a 2-way split here, an if-else split, we can get as many kind of results as we want. Yeah. Is there a question? Okay. So let's call that good for ifs. Let's look at repetition now. Can we go to repetition? Okay. And then we'll call it for today. Let's find another triad here that looks good. Anybody can go through the page too, and if you find one that sparks your interest. Well, you know what? Just in order here. Why don't we look at slide in the for loops, and like slide 30. Right? Write an algorithm to add up the integers from 1 to 10. Okay? It's easy to describe in words, but see if we can use a loop, and I want you to incorporate either the word for or the word while as you structure this loop. You can look at the slides if you're want to kind of get a hint, but I think you can also just sort of think about it for a minute. And if it doesn't come to you, that's fine. It's just to kind of get your brain thinking here. Let me give you just 2 minutes. So there's no need to read anything from the user. We just want to calculate a number and maybe print that value out. Oh, Peter's got some good font going on too then. Nice. All right, so let's quickly realize we're kind of coming up on the end of the time here. So we'll pick up with loops again on Wednesday, and I'll go through the slides as well. But sometimes I think it's nice just to kind of let it arrive at it organically, so to say, rather than me just droning on about the slides. So let me just write something a little casual, right? For a number in the list 1 through 10. Okay, so a number would first be 1, and then it'd be 2, and then it'd be number 3, then 4, then 5, then 6, and 7. I mean, imagine I have this list, and number is going to be one of those things, and then it's going to be another one of those things, it's going to be another one of those things. Sum is equal to, and if you go with this, now maybe you're thinking, wow, he cheats. I didn't know I had this available to me, this idea of going through a list. Fine, maybe I am cheating a bit, but go with me here, and if you believe this first line here, what should I do to set sum equal to an increasing amount? So Jameson, what do you think?
Increasing amount.
Like it should be equal to 1 and then 3 and then what, 6 and 7, you know how it would go. 1 plus 2 plus 3 plus 4 plus 5 plus...
It'd be... It's not like a factorial, is there?
No, think about like...
Adding the numbers?
Yeah, it's adding the numbers. So you would just say, hey, take what's my current sum and add 3 to it, and then add 4 to that thing, and then add 5 to that thing, right? So that thing I'm calling sum. This is my, box that I'm keeping my total in. And I'm going to first add 1 to that, and then I'm going to add 2 to that, and then I'm going to add 3 to that. Okay, so I'm going to write it like for sum equals sum plus number. And again, emphasizing the fact that this is not mathematical equality, this is assignment. I'm taking the sum to now be itself plus the number, and that number starts at 1, then goes 2, then is 3, then is 4, then is 5, and 6, and 7, and so on, right? Do we see this? If you're used to programming in a language like, and I saw some syntax that indicated some people have, like maybe in Java or JavaScript or C, then this looks a little bit different. This is how MATLAB thinks about loops, and so that's why I'm introducing it this way. Print sum. But there's a small problem here in the last minute here. I wonder if anybody can think what the problem might be.
Could the numbers be anything not in between 0 and 10?
Well, so maybe I'll make it like this. It's like 1, 2, 3, 4, 5, 6, 7, 8. So every time through this loop, number is equal to 1, is equal to one of these, and then it's equal to 3. And once it's past all this stuff, then we're done with the loop and we're out of here. Okay? So the first time through, it's equal to 1. Let's play the game. So at line 2 here, pretend I'm a computer, and I've just been told that I should take the value that's currently inside of sum, add 1 to it, and place the result back into sum. Okay?
We haven't defined sum yet, have we?
Ah, yes. So here it is. This is a box. This is sum. And this is number. So now I'm in my my Zoom thing, right? Number is equal to 1. And then I'm going to add these together and stick it back into sum here. But there's not, what's inside of this? Nothing. We don't know. So we need to initialize sum to what? What should sum start its life as? What's the right value to set it equal to? Somebody I haven't heard from. To finish this up with a bang, Hannah? I feel like maybe I've heard from Hannah, but she's my top left here, so.
Oh, I said 0.
Good, great. That's exactly right. So sum equals 0. All right, and so for a lot of algorithms here, the initialization step can be kind of tricky to think of. Here, it's clear that we should set sum equal to 0, but for some other things, it might not be as clear. So if that didn't totally gel, don't worry, we'll talk about loops again on Wednesday. This Google Doc will remain in the classroom, so you can go ahead and see this and check it out as a reference. I'll also add the recorded lecture for today. Okay? Good. Phew. If you have issues getting your textbooks or something, let me know. I'll be in touch as far as the class kits, and those will be in your hands at some point, hopefully soon. All right? That's all I've got. Enjoy the day. Thanks for hanging in here all the 6th period, and I'll see you on Wednesday.
Thanks, sir.
Thanks, sir.
Great.
Thank you, sir.